Hello students, and welcome to today's lesson on relations and functions. So let's begin by looking at this graph and answering a couple of these questions. It asks what value of y corresponds to x equaling -5. So remember, you're looking for a y value when x is -5. So the point on this line where x is -5 is here. And this is the point -5, 0. So the y value at this point is 0. Now look at number 5. For what value or values of x is y equal to 4? Well, I have to find points on the line where y equals 4. Well, here's the height of 4 for the y value. So this point, and the third point all have y values of 4. So for instance, this is the point or the ordered pair -4, 4. The second one is the ordered pair number -1, 4. And the third one is the point 5, 4. Each of these 3 points have a y value of 4. So for what value or values, there's 3 of them, of x does y equal 4? Well, the 3 x values are -4, -1, and 5. Now, normally when we have like 2 or 3 answers, maybe 4, we will put them in what we call set notation with commas between the values. Now, here's a different question. It doesn't give me a graph, but rather it gives me a bunch of ordered pairs or points that would be on the graph. So here it asks on number 9, what value of y corresponds to x equaling 10? Well, x equals 10 here at the bottom. So the y value is 2. So remember, it's asking for the y value. So the answer would just be 2, the y value. Now let's look at number 11. For what value or values of x is y equal to -10? So they gave me the y value. I'm looking for the x value, and there might be more than one. So a y value of -10. So look in your column. Here's one, and here's another one. So there are 2 points in which the y value is -10. And the x values that correspond are the value of -5 and 1. So I have 2 values, 2 x values, and they are -5 and 1. And I'm going to go ahead and put it in set notation with a comma between those 2 values. Now let's take a look at our next page. Here's a transition to topic 2, and it says evaluate. When it asks you to evaluate, generally your answer will be a number. They're going to give you a number to plug in, and then your outcome will be your answer. So let's look at number 11. So what they want me to do is input an x value of -5 for the first answer, then for x equaling 0, 1/2, and 4. So I don't know, maybe I'll call this part A. When x is -5, this would be 1 over -5. Well, that's the answer. We don't normally leave the negative in the bottom of the fraction, so I think I would rewrite it as -1/5 and just put the negative in the front of the fraction. Part B would be to plug in the x value of 0. Well, this would be 1 over 0. Now, 1 over 0 is undefined, so you cannot have a 0 in the bottom of a fraction. So this is undefined. I usually just write UND. Ooh, look at the third one, an x value of 1/2. Now, this is getting ready to get interesting. What if I have 1 over 1/2? So I have a little fraction embedded in the big fraction. Well, the best way to look at this is to write it horizontally, 1 divided by 1/2. Now remember, when you divide with fractions, you change the operation to multiplication and you flip this fraction on the right side. So this is the same as 1 times 2 over 1, which would give a result of 2. Now the last one is 4, and that one's not terribly difficult, so I'm going to pass on it. Now let's look at number 12. This one is kind of a play on the negative values. So let's take our first input value, which is an x value of -5. So this is going to be the negative of an absolute value of negative 5 minus 2. Well, when you take the absolute value, it makes whatever is in the absolute value positive. So this is a negative out front, and then the absolute value of negative 5 is positive 5. So the absolute value of negative 5 is the positive 5 in the parentheses. But then oddly enough, I have to take the negative of it now. So really it's a negative 5 minus 2, which results in an answer of negative 7. Now, part B would be the x value of 0. That one's not quite as difficult. So I have the absolute value of 0. Well, 0 has no sign. It is not positive or negative. So you really can't do a whole lot with this, except for that looks like negative 0, but it's just 0. And 0 minus 2 would be negative 2. So that's evaluating, kind of practicing a little bit with fractions and absolute values. Now, topic 3 is a transition, and it asks to determine values for which the rational expression is undefined. Rational expression. A rational expression is really a fraction with a bunch of variables in it. So these are all fractions with a bunch of variable x in them, or t, a, whatever. So they want me to determine what makes it undefined. Well, remember up here, when we have a 0 in the bottom of a fraction, it makes the fraction undefined. So I need to come up with the values that make the fraction undefined. Well, in number 13, your focus is only on the bottom of the fraction or the denominator. Focus, who cares what's in the numerator? You only want to talk about the bottom of the fraction. So the value that would make the bottom of the fraction equal 0 would be an x value of negative 7, because negative 7 plus 7 is 0, which would make this rational undefined. So the value would be negative 7. In other words, don't put negative 7 in that rational. In number 14, there will be 2 values for a, which will make the bottom of this fraction equal 0, and the entire rational become undefined. That would be an a value of 9, but also an a value of negative 9 would cause this to be 81 minus 81 and the bottom of the fraction to equal 0. So we cannot let a be 9 or negative 9, or it makes that fraction, that rational, undefined. Number 16, you might not be able to just look at that and come up with mental math in understanding what the answer would be. What would x need to be to make the bottom of this fraction equal 0? That might not come so quickly. So what we often do is, if it's possible, we will factor the denominator and then study the factored version to see what would make it equal 0. Well, if x is 0, 0 times anything is 0, so that would make the bottom of the fraction equal 0. So one of them is don't let x be 0. Then in the parentheses, the x plus 3, if I selected the x value of negative 3, negative 3 plus 3 would be 0, and again the bottom of the fraction would equal 0, making the rational undefined. So you're looking for the values you better not put into the fraction, the values that make the bottom or the denominator equal 0. Now, 13 through 16 were all rationals or fractions. 17 through 20 are square roots. Now remember, when you have a square root, you cannot take the square root of a negative number. Now later in the semester, we will actually be able to do this by using imaginary numbers. But right now, your approach is this isn't possible. It's not going to be a real number. So we look for things which are positive. So instead of searching for numbers I cannot have, as we did with the rationals, we now want to search for numbers we can have. So when we look at 19, the information under the square root, which is referred to as the radicand, can be positive, and it can equal 0. So the way I write this is I write that 2x plus 3 can be greater than 0 or equal to it. That is positive or 0. So once I have this inequality written, then I just solve it. So if I were to subtract 3 from each side of the inequality, I would have 2x greater than or equal to negative 3. And then if I divide both sides by 2, I would have x greater than or equal to a negative 3/2. So what values are okay? What values can I use in here and not have the square root of a negative number? They're values that are greater than or equal to a negative 3/2. Now, often we would write this in either interval or set notation, and we'll discuss that a little bit later in the semester. Well, actually, pretty soon, but not in this lesson. Let's work number 20. Again, it's the square root. So my focus is, what can I have? The 3 minus x, which is referred to as the radicand, can be positive, and it can equal 0. So once I have this written, I just solve it for x. So I would subtract the 3 off of each side. Then I would have negative x greater than or equal to a negative 3. Now to get x, not negative x, I must divide off the negative 1. Now remember, if you multiply or divide by a negative, you must reverse the direction of the inequality. So I always circle it because you have to come in here and evaluate what's a negative divided by a negative, and you don't want to forget to reverse the direction of the inequality. So these are the x values you can have with this square root, and it would make sure that everything under the square root symbol was always positive or it equaled 0. So now let's connect this work to college algebra. Number 3, we now are finding x and y intercepts, and they've given me a graph. So this goes back to the graphical work we were doing just earlier. So x and y intercepts. The x-intercept is the point where you cross the x-axis. Your line crosses the x-axis. Well, it crosses the x-axis here at the point negative 3, 0. It crosses the x-axis here, which we're going to have to do a little guesswork here. I'm going to say that's like 1 2/3, comma 0. And here at the point 6, comma 0, I have 3 x-intercepts. These are my x-intercepts, negative 3, 0, 1 2/3, 0, and 6, 0. Those are my x-intercepts. Remember, your x-intercepts will always have a y value of 0. So anytime a point is on the x-axis, the y value is 0. So then it also asks me for the y-intercept. The y-intercept is where the graph crosses the y-axis. Well, it crosses the y-axis here at the point 0, negative 3. So we have one y-intercept, 0, negative 3. So the y-intercept occurs when the x value is 0. Now it continues to use the graph, and it wants me to answer these questions. It says, what is f of 7? You're going, oh my goodness, this is function notation. Well, don't forget, we're looking at really f of x. So they've replaced the x value with 7. So if the x value is 7, then we want the y value given the x. So given an x value of 7, right here, what is the y value of the point on the line? This is the point 7, negative 4. So given an x of 7, the y value is negative 4. So now let's look at part C. Approximate the solutions of f of x equaling 0. So remember, this is your y value. So obviously they want to know the x value or values when the y value is 0. Well, we actually have already identified these as the x-intercepts, where the y value is 0. So there are 3 of these x values. They are -3. We had to estimate the 1 2/3 and 6. So we've answered part A and part C. I would also like to work with D and E. Domain, remember, is x values and range is y values. That's really important that you keep that straight in your mind. Okay? When you find the domain, you're looking for all x values that created the graph. So x values run from left to right. So the domain runs from left to right. And so I like to use a card when I find domain and range. So I'm going to cover up the graph. You're not supposed to be able to see the graph, okay? And I'm way over here on the left side because I'm going to slide from left to right. And way over here, I don't see a graph at all. So I start sliding until I see a graph. Oh, there it is. And there's an arrow on it. So it's moving leftward toward -infinity. So -infinity. And then I have a graph, I have a graph, I have a graph. The graph continues, it continues, it continues, continues, and then, whoa, it stopped right there. Okay, it stopped. It stopped at that point, 7, -4. It stopped at an x value of 7. This is x values, the x value of 7. Now, since this is a solid point, I use a square bracket on the 7. Had it been an open circle, I would have to have used a parentheses on the 7 here. The -infinity, any infinity will only take a parentheses because it's not a number, it's really a direction. So there's your domain. So now the last question is, what is the range? So remember, the range is y values, and so in this case, we're going to go from bottom to top, or low to high. So I take my card, I cover up my graph, and from down at the bottom, I slide up. So I see no graph, no graph, no graph, no graph, no graph. Oh, there it is. It picked up here and also here. Those were both the same y values in these two. The y value is -4. So it starts at -4, and since it's a filled circle, and unless there's a definite open circle, you always assume it's just solid, is -4 with the square bracket. Then I slide up. I see a lot of graph. I slide, I slide, I slide, I slide, I slide. Ooh, it stopped over here, but that's okay because it continues over here. I slide, I slide, I slide. And then I note that there's an arrow. That arrow is not just going leftward, but it's also going up. And it's going up to positive infinity. Now I could put a plus sign in front of that if I wanted to, but it's assumed positive unless you put a negative in front of it. So that's the end of today's lesson, which is support to relations and functions. And I hope that prepares you to move now into the college algebra material. You have a great day. Thank you for staying with me to the end.